All right, I just want to walk you through what you're doing on the two worksheets that you have today. You should have already probably finished the lab or finished most of the lab, but I want to practice a little bit more with the ideas of that lab and the ideas of double replacement reactions. So your first worksheet is the worksheet on the precipitation of ions. This is going to look a little bit similar to that earlier worksheet where we had the solubility coming into play, and we check the solubility with the solubility rules, and then you drew it as either aqueous, right, with the ions all separated, or as a precipitate, right, where it's insoluble, sitting at the bottom where it's all clumped together and the ions are actually together. Okay, I want to show you just one of these. I'm going to pick number 3 because it's the one with a solubility rule that I didn't actually teach you, so sorry about that. But, you know, you don't see a ton of chromates other than in textbooks, honestly. So that's why I don't think it's the most important. All right, so let's go ahead and write out the general equation. In order to predict the products of this reaction, you would just need to swap their partners, right? So if we would take lithium and partner it up with chlorine, we would get lithium chloride. And I know it's LiCl and not like Li2Cl or LiCl2 or something like that because lithium has a +1 charge and chloride has a -1 charge. Now, I don't yet know until I look at my solubility rules whether this is aqueous or solid. But we do know that that first rule, that first of the solubility rule says that lithium, like sodium and potassium, right, is always soluble. So this is going to be aqueous. Okay. Now, the second pairing is going to be the pairing of barium now with the chromate ion, right? So you get barium chromate. Surprise, surprise. Okay. And barium has a +2 charge, and chromate has a -2 charge, so I know it's just BaCrO4. No other subscripts need to be added. And then we have to consult solubility rules to determine what state of matter that's in. Well, the state of matter for this one is solid, as you might have guessed. Okay, chromates are often insoluble. There are some exceptions, but barium is not one of them even. Okay. So we've got an equation now. We haven't balanced it yet. We should go ahead and balance it. There's 2 lithium and 2 chlorines, so we need to put 2 times LiCl. All right. Now, when you go to write the gross ionic equation, the gross ionic equation is going to separate out all of the individual ions. So there are 2 lithium ions before reacting, and there's a chromate ion, of course. Okay, so that's how you would write lithium chromate broken apart. And there's a barium ion and a couple of chloride ions. Okay, so those are our reactants. You know what? I'm writing these a little bit on the big side. So let's see if I can shrink that just a little bit, give myself a little bit more room. Okay. And then let's write the products of this reaction. So the products, of course, we see that the lithium chloride is still aqueous after reaction. And so that means we have 2 lithium ions and we have 2 chloride ions, right? But the barium chromate is stuck together, right? That's the solid, that's the precipitate, it's stuck together. Now, once you've written I always call this the complete or total ionic equation. Gross ionic equation is another form of it, like gross and net, whatever, right? So now you can go to the picture and draw this. So we've got some lithium ions, and we have some chromate ions. I don't know why I drew them so close together. They don't have to be that close together. Okay? So there are my ions floating around in solution in the first beaker. The second beaker is the one with the barium chloride in it. So we put our barium and our chlorides. Okay? And then after reaction, of course, the lithium is still floating around, right, according to this equation. So we have lithium, we have chloride, something along those lines. And then at the bottom, we've got all together our barium chromate. Okay? And so that's essentially what that would look like. The barium chromate would be a precipitate sitting at the bottom of the beaker. The net ionic equation, I think I mentioned this in class already. The net ionic equation is just going to be what actually changed. And what actually changed was barium and chromate became partners in crime. Right? That's another way to put it, I suppose. Right? They linked up and they stuck together. Okay, so that's our net ionic equation. Notice that it doesn't include the spectators, right? The spectators are the lithium and the chloride ions. Okay, so that's how you'll do these other two in this first worksheet. In the second worksheet, I just want to show you one of these, and that's 2A. I want to show you 2A here. It says identify the reactants and write the balanced equation. So we just figured out what the products were. What about figuring out what the reactants are? Well, it's kind of the reverse process, right? So you kind of just swap partners once again. So you have your iron paired up with the nitrate. And nitrate has a -1 charge, and iron, according to this, right, has a 2+ charge. So that would be FeNO3 and all nitrate compounds are aqueous, but yes, this one's aqueous. And then we also have our lithium hydroxide, and that's going to be aqueous as well, just as all lithium compounds are. And you would have to balance it, of course, right? It does say write the balanced equation. And so, you can figure out how to balance that yourself. All right, but that's the process for that. So again, it's just kind of doing that swap, right? You're swapping the two metals or the two cations, and you're swapping the anions, right, with new partners. So that's sort of the idea for this whole worksheet. Okay, so I'll leave you to that, and hopefully you guys do pretty well with this. But if you have any questions, reach out. All right, I'm not dead and gone. I'm just doing some workshops and stuff. So please send me an email. Let me know if you need any help. All right, you guys have a great day, and I will see you next week.